Hello guys, welcome to my YouTube channel, and today I'll be taking you on how to convert a decimal number into a binary number. Alright, so without wasting much time, let's get started. Let's take this particular example. Let's convert 62 to a number in binary. Okay, so I'm going to show you two methods of doing this. Okay, the first method is we are going to break this 62 into a number or series of numbers that can easily be represented using binary. If you want to break down this 62 into numbers that can easily be represented using binaries, so you start with 2 raised to the power 0. 2 raised to the power 0, we have 2 raised to the power 1, 2 raised to the power 2, 2 raised to the power 3, 2 raised to the power 4, we have 2 raised to the power 5, then we have 2 raised to the power 6. Okay, so 2 raised to the power 0, we have 1, 2 raised to the power 1, we have 2, 2 raised to the power 2, we have 4, 2 raised to the power 3, we have 8, 2 raised to the power 4, we have 16, 2 raised to the power 5, we have 32, and 2 raised to the power 6, we have 64. The reason I stop at this is because 64 is greater than 62. So since 64 is greater than 62, you stop at this. Okay, so you have 1, 2, 4, 8, 16, and 32. All right, so the next step is you need to add these numbers in a situation that they will give you 62. You add up these numbers that you have in here, combine them so that they will give you 62. All right, so I have my 62 in here. Now let's start with 32. So yeah, 32. Then if we add 32 plus 16, 32 plus 16 will give us 48. So let's add 16. So you have 32 and 16, this is 48. So we still need like 14 to make 62. So if we add 8, let's put this 8, so you have plus 8, this is 6, and this is 56. So we need 6 more to have 62. So we add 4, so you have 4, making it 60. So we add these 2. If we have 32 plus 16 plus 8 plus 4 and plus 2, we are going to have 62, right? So we have our 1, because normally it should start from 1. Okay, so we made use of 32, let's turn it on. We made use of 16, let's turn it on. We made use of 8, let's turn it on. We made use of 4, let's turn it on. We made use of 2, let's turn it on, and we didn't use 1. Okay, so let's turn it off. So 62 equals to 1 1 1 1 1 0 in binaries. So this second method is about successive division by 2. So we have our 62, then we have a line, then we have our 2. Okay, so we have 62 divided by 2, that is 31, and remainder 0. Okay, because 62 is an even number, when it divides 2, we have 31, and the remainder is 0, right? So 31 here, this one is not an even number. Okay, so what I normally do is 31 minus 1. Let me write it here. This is 30. So if you divide 30 by 2, we are going to have, let's write 2 here. Let's subtract 1 from 31, and we are having 30. Now 30 is an even number, so when 30 divides 2, you have 15. Then the one that you subtracted, you have remainder 1, because if you multiply 15 by 2, you are having 30, and if you add this one, you have 31 back. Okay, so the next step is we are going to divide 15 by 2 again. So 15 divided by 2, 15 is not an even number. The 5 here is not an even number, so we subtract 1. 15 minus 1, that is 14. So 14 divided by 2, we have 7. Since we subtracted 1, we have remainder 1. Then the next thing we are going to do is to divide this 7 by 2. So write our 2 here. So 7 is not an even number, so we subtract 1. 7 minus 1, that is 6. Okay, so 6 divided by 2, we have 3. Since we subtracted 1, we have remainder 1. Okay, so we are going to divide 3 by 2 again. So 3 is not an even number, so we subtract 1. 3 minus 1, then we have 2. So 2 divided by 2, we have 1. Then since we subtracted 1, we have remainder 1. Then 1 is smaller than 2, so we have 2 here. We have 0 and remainder 1. So having done this, we are going to take these numbers from the bottom to the top. So 62 equals to 1 1 1 1 1 0 base 2. Alright, so let's take example 2. So we have B. In this example 2, we are converting 670 to a number in binary. Okay, so this is an interesting one. We are converting 670 into a binary number, right? And we are going to make use of our first method before we consider the second method. Alright, so what we are going to do is we are going to split this 670 into numbers that can easily be represented using binary. Okay, so let's start. We have 2 raised to power 0, we have 2 raised to power 1, we have 2 raised to power 2, we have 2 raised to power 3, we have 2 raised to power 4, we have 2 raised to power 5, we have 2 raised to power 6, we have 2 raised to power 7, we have 2 raised to power 8, we have 2 raised to power 9, and we have 2 raised to power 10. Okay, 2 raised to power 0 is 1, 2 raised to power 1 is 2, 2 raised to power 2 is 4, 2 raised to power 3 is 8, 2 raised to power 4 16, 2 raised to power 5 32, 2 raised to power 6 64, 2 raised to power 7 is 128, 2 raised to power 8 is 256, 2 raised to power 9 is 512, and 2 raised to power 10 is 1024. Okay, 1024 is bigger than 670, so we will consider from 512 down. Alright, so that's being said, the next thing is we are going to combine these numbers to give us 670. Alright, 512 is smaller than 670, so we are going to consider 512. So let's turn 512 on. So we turn it on. So we will now have 670 minus 512. So this is 158. Okay, so we have 158 left. So we have to distribute 158 to these numbers. We are going to combine these numbers to give us 158. All right, so 256 is greater than 158, so we are going to turn it off. We are not using it. Then 128 is smaller than 158, so we have 158 minus 128. All right, so we have 30. So we are going to turn on this one because we are using 128. Turn it on. So we are working with 30 now, right? 64 is bigger than 30, so we turn it off. We are not using it. 32 is bigger than 30, we turn it off. We are not using it. 16 is smaller than 30, right? So we can use that. We have 30 minus 16, so we have 14 left. All right, so we are using 16. We turn it on, so we have 14 left. If we subtract 8 from 14, we are going to have 6 left, so we are using 8. So we are going to turn it on. So now we are having 6 left, so we are going to use 4 because 4 is smaller than 6. So when we subtract 4 from 6, we have 2 left. So let's turn on because we are using 4, and here we have 2 left. So let's turn on these 2 because it will take care of these 2. So we have 2, turn on, and that's all. But since it normally starts from 1, so we are going to consider this one. But since we did not use it, we are going to turn it off. Okay, so we have 1 0 1 0 0 1 1 1 1 0. So 670 is equivalent to or is equal to 1 0 1 0 0 1 1 1 1 0 to base 2. Alright, so let's convert 670 to a number in binary using the second method. Alright, so we are going to have 670 this way, then we will divide everything by 2. Okay, so this method is just a successive division by 2. All right, so we have 670 divided by 2. 670 is an even number, so 670 divided by 2, you will have 335, remainder 0, because 335, when you use it to multiply 2, you have 670. All right, so let's go by it again. 335 divided by 2. 335 here is not an even number, so what I normally do is you have 335 minus 1 equals to 334. All right, so 334 divided by 2, you have 167, 167, and because you subtracted 1, you have remainder 1. If you use this 167 to multiply with these 2, you have 334, and if you add it with this one, you have your 335 back. Okay, so that's how it is done. Then you go by it again. 167 divided by 2. Then remember, 167 is not an even number, so you have 167 minus 1 equals to 166. So 166 divided by 2, you have 83. Since you subtracted 1, your remainder will be 1. Okay, so you have your line. Then 83, you need to use it to divide 2 again, but since it is not an even number, you have your 83 minus 1, which equals to 82. So you have 82 divided by 2, so you have your 41. Since you subtracted 1 from it, you have your remainder 1. Okay, then you have your line. Then 41 divided by 2, you have your 2 in here. Since 41 is not an even number, you have 41 minus 1, which equals to 40. So you have 40 divided by 2, then you have 20, and since you subtracted 1 from it, you have your remainder 1. Then have your line. Then the next thing is you use 20 to divide 2. 20 divided by 2, you have your 10, and since 20 is an even number, the remainder here will be 0. Okay, so you go by it again. 10 divided by 2, and 10 is an even number, so you have 5, and the remainder will be 0. Okay, then 5 divided by 2, 5 is not an even number, so 5 minus 1, you have your 4. So 4 divided by 2, you have your 2, and the remainder is 1 because you subtracted 1 from 5. Okay, now you go over to 2. 2 divided by 2 is 1, and the remainder is 0 because 2 is an even number. Alright, now 1 is smaller than 2, so if you use 1 to divide 2, you have 2. Here you have 0, and the remainder will be 1. Okay, so you have your line, and you have your final line. Okay, now you take the numbers from the bottom to the top. Okay, so 670 in binary equals to, you have your 1 0 1 0 0 1 1 1 1 and 0 in base 2. All right.